11:00 ми готові слухати ваші презентації. Не зовсім ще готові. Нам потрібно певний час почекати, поки піднімається Міченко Тетяна Євгенівна, голова журі. Там технічні проблеми з Zoom, тому маємо ще певний час до того, як вона підключиться. Поки ці технічні моменти, я вам вранці написала так, щоб ваші презентації можна було зрозуміти, тобто ви розповідаєте не дуже швидким темпом, так, щоб можна було зрозуміти, про що ви розповідаєте, так? Зверніть особливу увагу. Я думаю, що ви всі підготовлені, що ви всі вже робили такі пробні свої виступи англійською мовою. Акцентуйте увагу на важливих речах з точки зору ходу вашого дослідження, на ваших ключових висновках, на тих результатах, яких ви отримали. Повторюся, що не треба дублювати на початку, як вас звуть, ім'я керівника і назву роботи. Це, в принципі, я оголошую, це є у вас на слайді. Тому за рахунок скорочення цієї інформації ви цілком вкладаєтесь в 5 хвилин для того, щоб сказати основні речі і перейти до обговорення з членами журі. Так, я думаю, що ми ще чекаємо ще Тетяну Євгенівну і будемо розпочинати. Я думаю, що хвилин 5 до 5 хвилин у нас ще точно є.
Юлічка, можна задати питання?
Так.
Завжди була Оксана Богданівна, а в неї все гаразд.
У Оксани Богданівни все гаразд, вона проходить лікування своє стандартне, санаторне, тому ми з нею на зв'язку, але вона, я так розумію, що зараз знаходиться десь в горах.
Де нема зв'язку. Дякую за
Так.
роз'яснення, дякую.
Вона у нас почесний наш координатор нашого конкурсу. Вона свого часу привезла цей конкурс в Україну в 2003 році. В 2004 відбувся перший національний етап конкурсу в Україні. Тобто рахуйте, що вже 21 рік конкурс присутній в Україні. А сам конкурс існує з 97-го року. Ну, і Оксану ми вже, як то кажуть, вона в нас, якщо так можна казати, почесний пенсіонер, так, ми вже її не навантажуємо.
Я її генеральське звання, ці її чудові машинки у Львові, коли вона виставляє, просто...
Так, вона випромінює життя, енергію.
Так.
Попри все, що відбувається, вона дуже великий молодець.
Так.
Не буду забирати багато часу і пропоную розпочати з першої роботи. У нас сьогодні перші захищаються Вовк Антон і Павлюк Маргарита. Проєкт «Особливості використання дистанційних даних для оцінки водності територій» на прикладі Волинської області, Волинський науковий ліцей. Захист відбувається англійською мовою. Презентація залишається та сама, тобто презентація українською мовою. Питання журі ставить англійською мовою. І дискусія також переважно має вестися англійською мовою. Let's start.
So, good morning, dear jury and guests. In times of climate change, water content of the territory and moisture availability of the territory strongly affect the environment and people's lives. Next slide, please. Rising temperatures despite the water balance, which is especially noticeable in the region. The Volyn region, which used to be very wet, has faced many droughts and a drop in ground and underground water levels over the past decade. Next slide. So we decided to create methods of monitoring water objects and resources using remote sensing data. You can see the research objectives and methods on the slide. Next. We choose the territory of the Volyn region for our research to check how good and accurate are indices. We picked different lands areas and with different surface types. To work with the satellite images, we used our browser, Land Viewer, and Google Earth engine. In our browser, the algorithm is as follows. In Google Earth Pro, contours of territories are created. They are loaded into our browser. The Sentinel-2 satellite and the statistic tool are selected. After selecting the period, a graph is generated that can be exported to CSV. In addition to standard indices, you can edit or create your own index. Next slide.
Let's move on to the results. Analysis of K areas according to the NDWI index showed that the highest values are characteristic of a water object like sweeties. At the same time, the values are very variable in a time with quite sharp jumps even between neighboring dates. To a large extent, this is due to the very variable state on the surface layer of the lake due to waves, wind, development of aquatic vegetation. The next section is a forest massive in Voronezh district. As we can see here, the dynamics have much more pronounced seasonal course, apparently due to the different development of vegetation. Analyzing the field, as for the forest, the graph has a clear seasonal expression, but the duration of the periods at low and high values is significantly different. This is influenced by what culture is grown, what the period and phases of vegetation, when the harvest is harvested.
Next slide, please.
In a reclaim river with meadow vegetation, there is again a seasonal curse. Next slide, please. For your attention, the results of the analysis using the NDMI index, they expected depend much more on a moisture in a vegetative layer than on a total water content. Although the total water content also affect the moisture availability of plants, this effect is mostly indirect or at least remote in time. Next slide. As can be seen from the previous point, both of the most common indexes are not ideal to assessing water content. They vary greatly in different areas. We tried to combine several other indexes. Comparing this image, the best picture of moisture indexes is shown by RDI and SR sphere. Next slide. Compression of watered area is another method of assessing water content that can be applied to areas that are sufficiently watered, but which are significantly dependent on water inflow from other areas. We use this on Lake Turski and the wetland near the city of Kovel. Even though the average size stayed around 1,000 hectares, there were a big change. Next slide. Using the GLDA satellite data set, we attempting to obtain soil moisture values and different depths. The results are presented in a graph on a slide. The data can be visualized both in images and graphs. Next slide. SMAP satellite data makes it possible to analyze soil moisture in a certain area over a certain period of time based on daily indicators. For example, on a slide, I imagine comparing dry and wet periods in 2017 and 2020 years, graphs of soil moisture for the summer of 2024, and a decrease in moisture in spring of 2020 years. Next slide, please. Having received the results from Google Earth Engine, we decided to compare them with amount precipitation. For example, on the slide compares of precipitation and soil moisture graphs in the summer of 2020 for Volyn region. Next slide. Our project has a great prospects in the future. The results can be used in any corner of planet, which has international significance. The developed algorithms and methods quickly and easily provide remote sensing data determine the water content of a certain territory. So you can read the main conclusions of our work on a slide. That's all for us. Thank you for your attention.
Thank you. Okay, so now we are going to our discussion with jury members. Who's gonna start with question? Vita Vasilievna, please.
Yes, I just have one question. Google Earth Pro software was used to create contours of the water object, yes?
Yes.
Yes.
How was this approach done, and what is the error of this approach?
So we create contours of our areas in Google Earth Pro. Then we download KMZ file or KML file in our computer, and then we loaded this file on our browser, and we work next in our browser.
So the results from the Google Earth Pro were used to calculate NDVI and NDMI indices, right?
Yes.
So for both indices, you just take a certain part of the images, yes? And the area of these images were used to calculate the values.
Yes.
What
But
is the error of such approach?
Repeat, please.
May I ask a question in Ukrainian language?
Окей.
Яка похибка цього підходу, коли ви визначаєте оці контури для розрахунку NDMI індексу і NDVI індексу, да? Коли ви враховуєте площу самого водного об'єкту, а в NDMI ви враховуєте ще й вологість ґрунтів. От яка похибка цього підходу?
So contours are контури однакові. Тому в тому і різниця, що ми досліджуємо різні індекси, порівнюємо їх дію.
Okay, thank you for the answer.
Okay, I have a quick question. How did you come to your idea of your project, to idea of your research?
Yes, so I and Margarita is classmates in Volyn Science Lyceum. I research GIS and geoinformative systems and remote sensing for 3 years. Margarita also research climates in Junior Science Academy. So we
decide to combine our knowledge, and then our work like was born, I can say.
Okay, thank you. So is
May I
any
ask, may I ask
Yes.
also? You did a lot of work, you analyzed very big data massive, but my question about automatization of this work. You propose the results as part of international cooperation and so on, but what about computational data analyzing? Because part of your work you do just mechanically.
For automatize our algorithm must be used maybe new geoinformative systems, but it's unreal now, maybe.
Thank you.
Okay, thank you. Two more questions. First one from Roman Smatraev, please.
Thank you. Now there are many software that predict the state of water basins. For example, ВЮВП. Have you considered using such software together with your research to predict water content?
So one of our perspective for our research are creating an web app, mobile app maybe, to monitor this chosen area and maybe predict with data, meteorology data, and this is one of our perspective for our research.
Thank you. I advise you to see modern software before you develop your software, maybe. Thank you.
Thank you. Ірина Володимирівна.
I'd like to ask you about how does your work differ from similar ones? Maybe some points.
From what? Sorry, I don't understand.
Differ between a similar one. Your work, it's modeling, and we have some works the same. But your work, I think it's different algorithm, yes?
Yes.
Yes.
Or not?
Yes, algorithm. We
Only
create our
algorithm. Maybe you have some points, benefits.
so yes, our algorithm is so firstly we select maybe period 3 years or 5 years or 10 years. Then we analyze Sentinel satellite images and data from Sentinel satellites or Landsat satellites. We analyze this many different indexes in these satellites. So we should to choose key areas to check our indexes, how it works in our region. So if we use this algorithm in the world, we should firstly check this algorithm in that territory area.
Okay, thanks.
Thank you. So I think no one questions. So we...
Вибачте, можна запитати дещо? Чи можна поміняти місцями третє і друге місце, тому що мені потрібно буде після 12-ї терміново
Добре.
відключитися?
Okay, so we are going, thank you,
Thank you.
Anton, for your presentation. So now we have some change in our projects. If no questions from Polina and Anastasia, who should be the next? We are going to Yeremenko Vasil. Am I right?
Yes.
So, just a minute. Yes, you can start.
So, introduction. At the current stage, the main directions for the rational usage of water resources are saving fresh water and expanded reproduction of freshwater resources, as well as developing new technological processes which will help us to minimize the consumption of fresh water. Next slide, please. For this reason, I'm going to show you my study, which operates on the principle of compression. This purification method may allow to remove of mechanical parts from water, making it suitable to further chemical treatment. Additionally, the collected garbage can be repurposed as in agriculture as fertilizer. Importantly, the entire process is designed to be fast and mobile, utilizing a press mounted on a track. Next slide, please. So this mechanism is based on whales eating method. Instead of hunting individual prey, the blue whale consumes entire swarms using its massive mouth. Its diet consists of teeny ocean organisms called krill. Its mouth can take in up to 220 tons of water in a single gulp. When the mammal opens its mouth, the incoming water pushes its tongue and it stretches across the whole mouth, filled with water and krill. After closing its mouth, the whale pushes its tongue forward, acting like a piston to force the water out through the baleen plates. As a result, only the krill remains trapped in the mouth. Next slide, please. Together with my scientific advisor, I constructed an experimental model of a filtration system known as the first stage filtration unit. Let's refer the schematic diagram in which first is electric motor, 2 is chains, 3 a heavy flat plate, 4 the upper part of the baleen structure, 5 a wastewater storage tank, 6 the lower part of the baleen structure, and 7 is a place where the upper part of the baleen can hide. Next slide, please. During the experiment made on the constructed mini model of the system, water obtained from a substance which roundly shows the level of sewage was clear enough for further treatment. In the second stage, for further treatment in the second stage filtration process. Additionally, I propose to change and motors with electromagnets and making the upper part of the press plate out of metal. Next slide, please. Additionally, I have come up with the idea to create small mobile presses that would serve as portable water purification units. My friend measured the sizes of my experimental setup and produced a scale model using a 3D printer. I believe that further using and developing this technology, 3D printing, in the manufacturing of these purification units can be possible. There are a lot of 3D design programs such as AutoCAD, SolidWorks, and Fusion that allows creation of such models on computers. This technology also allows to control the geometry of these constructions to capture both large parts and microscopic contaminants. Next slide, please. Such system can be optimized for installation on a truck with the following features: strong waterproof and metal truck full, water tanks where will be mechanically purified water after pressing, to load silted water from the environment or lakes on river, polluted lakes and rivers in the villages, for example. This truck needs to be equipped with a powerful pump and energy efficient pump. Sewage which will remain in the press should be unloaded and in the further way can be used as organic fertilizer, but it should go through a thermic through the temperature treatment. Conclusion. Such mobile installation can be useful to provide fresh water during emergencies for field camps, construction sites, or military operations. But water after this filtering should be chemically purified in the second stage. Protection and efficient usage of freshwater resources is a big part of solving eco problem with water on the earth, and my work can help in this solving. I'm ready to hear your questions.
Okay. Thank you, Vasil. So, who gonna be the first with question? Тетяна Євгенівна, мікрофон. Я бачу, що ви розмовляєте, а мікрофон не працює. Так, поки що давайте Роман Васильович задасть питання, а потім Тетяна Євгенівна, тільки мікрофон потрібно увімкнути.
Thank you. Can you provide the main characteristics of the sludge formed after filtration? For example, the weight of the sludge or other characteristics which you studied? Maybe.
So after pressing, yes?
Yes, yes.
It
press.
remains in the press. So it is it's like a organic garbage. This method suits only for organic polluted water lakes or rivers in the village or places or filtration fields, and this this garbage is aroundly 30 or 40% wet, but to use it as a fertilizer, we need to make a thermic treatment.
Thank you.
Так, more question. Тетяна Євгенівна, мікрофон у вас не працює. Він у вас вимкнений. Спробуйте його.
розумію, що він
А, зараз
вимкнений.
працює. Зараз працює. Зараз ми вас чуємо.
працює. Ну, і чудово. At first I would like, окей, українською, я хочу представитися. На жаль, мені не вдалося своєчасно підключитися, але зараз вже все окей. Я є членом суддійської команди, а саме її головою. Мене звуть Тетяна Євгенівна Міченко. Дуже рада вітати наших всіх учасників. Щодо now the question to our Vasily, yes, to presentator. This is you propose this very good original, and I like this job and this work, but the question is the following. Your proposition is the mechanical filtration proposition, yes? Do you have some information about the better properties of this method in comparison with traditional method? Okay, it's mechanical. You did this mechanical filtration. What is the difference and what is the best properties, better properties?
Thank you for the question. I can say that for me, and I haven't seen this method in general water purifying system in the world. So it's new conception of using nature things that nature constructed a lot of years ago, like Berlin's whale's baleen. And in my opinion, this press will functionate faster than typical filtration fields, or it will work faster.
And what do you plan to do with sludge which you obtain by this method? Okay, you filter the water, more or less clean the water, and you obtain the solid components, yes? What will you do with it?
That components which will remain in the press, water will go on the further treatment, and these parts will be used as a fertilizer, but before it we need to make a thermic treatment for them. If it's organic, this method works only with natural or organic pollution, like people in village a lot of times are use rivers or lakes as a sewage system. It's not correct, but it's one of the ways, in my opinion, to clean that lakes and rivers in the village, small water.
Thank you. I haven't questions more.
You're welcome.
Thank you. Any more question? Okay, if we have no questions, thank you, Vasil, for your presentation. And we are going to the next one. We back to our girls. Okay, Голощапова Поліна, Білменко Анастасія, система для очищення та аналізу якості води ДРОН СОМ, Ніжинський фаховий коледж Національного університету біоресурсів та природокористування України, Чернігівська область. Are you ready?
Yeah,
So you can start.
thank you. Good day, dear jury and everyone. We present the project SOM Drone, an innovative idea for cleaning water and monitoring its condition. Next slide.
Clean water is always an important question. Pollution of water with smoke, trash and chemical is a big problem. It's dangerous for water animals and nature.
The drones that already exist and can collect trash and information about water only work on the surface of the water.
Right now, there are not enough good ways to check water quality in lakes and rivers. Next slide.
Our main goal is cleaning water from small trash and monitoring water parameters.
To do this, we need make a concept to this drone and build it in real life. Next slide.
For this, we made a concept of an underwater drone. It can move well, has places for sensor to check water, and can collect small trash from the bottom of the water. Next slide.
Main features for our drone. We took a shape of catfish for the body. It has 8 motors and it has systems
Я не могу выйти из полноэкранного режима.
a fish that
Главное звук подключить.
has sensor to check in water. Next slide.
Next, yes. This slide shows the drone scheme. It has 4 horizontal and 4 vertical motors. There is a hole to suck in trash and other holes for the water to go out. It has a built-in camera. Later we plan to use 2 cameras for machine vision and 2 LED lights. Next slide. The scheme shows how the trash enters the inside. A separate motor on command pushes the water out to both sides. The intake hole along with the water pulls the trash in. A grate prevents the trash from getting into the motor.
A partition stops water from reaching the back while all electronic are located namely. The collector, speed controller ESK, battery pack, ESP32 for sensor. Next slide. For the prototype we use PVC pipes, 3D printed material, PLA and PETG, 8 motors for movement and 1 for water intake. All controller PixQuark camera LEDs 3 watts, 2 pieces, ESP32 temperature sensor. Next slide.
We create a simplified demonstration model that has good maneuverability, can measure water temperature, and with the other sensors it can measure other parameters. Can transmit data to a PC for further processing. It is capable of collecting small trash from the bottom of the water. Next slide. So our concept has proven to be promising. The project was created independently as a startup for further development. It has potential for scaling and participation in various programs. Next slide.
We plan to further improve the design and system of the drone, which the possibility of using AI. Develop a version stable for mass production and use. Find partners and investor for scaling and production. Next slide. Thank you.
Thank you. So, first question. Роман Васильович.
Thank you. What is the battery life of this drone in cleaning and analysis mode?
What is, repeat, please?
What is the battery life? For a long time,
30 minutes.
30 minutes.
Yeah, we use for test battery, and yeah, here it work for 30 minutes, 33 minutes.
Thank you.
But in future, we can use better battery pack, and it can be works more time.
Okay, thank you. More questions?
May I ask?
Yes.
In continue of previous question, if you change battery, what about balance between different parts of your drones? Because at start of your monitoring, you have two parts. One have control area and other empty storage area. And during the walk, drone will be a little bit different by weight of different parts. What about balance with the drone and other technical characteristic in this case?
Thank you for your question. So our project is concept. We can we want to show you a concept, but in future we can improve not only battery pack. We can improve other parameters. We can add a sensor for checking oxygen and nitrate. We can we add battery pack. We can change other technical details, improve it by better. Just we don't have enough finance to do this.
Thank you.
Okay, thank you. Two more questions. Андрій Вікторович, please.
Не можу слово недолік підібрати правильно. Який недолік має ваш проєкт? Точніше, ваш винахід. Я не можу слово недолік підібрати адекватно англійською.
What is the weak?
Бо там flow, ну, воно не підходить. Да, так. Відповідайте англійською, будь ласка.
Yes. Is question to prototype or for our project to concept? If it's question for our prototype, yes, we have a lot of weak. We need better battery pack. We need add more sensors, but in concept, I think we don't have any weak.
Okay, thank you. Віта Васильівна.
I've got one question. In your work, you mentioned that your drone need to use artificial intelligence system to analyze the collected data. Yes. What artificial intelligence system do you mean? Are they already have been developed, or do you plan to develop them?
We are planning to develop it.
We won't use AI in camera. We want what our drone can see trash by AI for autonomy distance.
Okay, thank you very much for this.
Okay, thank you. Okay, no more questions, so I think we can go forward. Thank you, girls. And The next presentation, next project. Макряк Варвара, Кісельова Анна, система накопичення питної води Well Water, Центральноукраїнський науковий ліцей-інтернат Кіровоградської обласної ради. Are you ready?
Yes.
You can start.
Good afternoon, dear jury members. We are Varvara Makryak and Anna Kiselova, students of the Kirovograd Junior Academy of Science. Today we are presenting our scientific project, Drinking Water Storage System, Well Water. Next slide. The problem of drinking water shortage is becoming more serious all around the world, including Ukraine. In many places, the groundwater level is falling because of different reasons. To solve such problems, you need an expert, time and money, and during a full-scale war, it can be a big problem. As a result, many families who live in private houses face problems getting safe and clean drinking water, especially where there is no centralized water supply system or where it is not stable. Next slide, please. The water shortage in rural areas is caused by long droughts, damaged well seals, clogged well bottoms, or shifting underground water layers. That's why we need affordable and energy-efficient solution. Next slide, please. There are different ways to store water. Let's look at a few types. Metal tanks. Their main disadvantage is susceptibility to corrosion. Double wall storage system. These are more complex engineering structure. Other disadvantages are written on the slide. So plastic containers and barrels are the focus of our project. They are made of strong food-grade plastic, safe for storing drinks or technical water. The main advantages of plastic containers are low cost, lightness, durability, resistant to corrosion, and chemical effects. Slide. Next. The main problem of all water storage systems is keeping the water clean and safe for a long time before it is used. We suggest I'm sorry, please.
Заспокойтесь, будь ласка, зберіться і продовжіть. Час іде.
We suggest placing the storage tank directly inside the wall. This protects the water from dust and helps to keep it cool, which makes it last longer. On this slide, you can see the functional diagram of our water storage system, Well Water. The system is fully autonomous and powered by a solar power plant, which main components are a solar panel, a hybrid inverter, and a battery. Next slide, please. Here's how our system works. Water in the well naturally refills after being used. When it reaches sensor C1, pump P1 turns on and fills the storage tank. When the tank reaches sensor C3, pump P1 stops and the water is stored in the reservoir. When the time comes for active water use, the well's water level starts to drop. When it falls to sensor C2, the actuator activates the shutoff valve and opens the reservoir. Water flows into the well, helping maintain the correct level for deep pump P2 to draw water. Next slide. We use water level sensors in both the tank and the well to control the process. Relays turn the pumps and valves on or off. The Arduino microcontroller manages all electronics parts and follows the program. The well water system is a practical solution for storing clean water. It's reliable, easy to use, and can adapt to different situations. Next slide, please. This slide shows how we programmed and tested the well water prototype. First, we connected all the electronic parts to the Arduino board. Then we placed the sensors inside the module, connected the pumps and valve to the relays. We carefully calibrated the sensors to be sure they work properly. Finally, we wrote and uploaded the program code based on our algorithm. You can scan the QR code to watch a video of our prototype in action, including sensors, the valve, the pump, and our Arduino code. Next slide. Our main conclusions are shown on the screen. The well water system helps to solve the problem of drinking water shortage in rural areas. It uses automatic control, improves storage, and can work independently without constant human help. This makes it especially useful in emergency situations, especially during war. Thank you for your attention. We are waiting for your questions.
Thank you. Who will start with question? I can ask the first while thinking about question our members of jury. My question is about financial part of your project. Did you calculate the cost, average cost of such equipment?
Yes, we did.
How much does it cost approximately?
Approximately it costs nearly, do we say in greeners or dollars? This is the question. like
Mhm.
in hryvnias it is nearly 19,000, and in dollars I can say it is nearly like 250, like $300.
Okay. And my second question, personally, each of you, what was your personal part in this project?
I wrote the code, and Varya was for the technical part of our project.
And could Varya tell something about her part of the work?
I was
So it's something, okay, it's a little bit complicated for you to answer in English. Okay, so next question. Irina Volodymyryvna, yep. Okay.
Yeah. Thanks. I'd like to ask you about why should the tank be located in the well and not near it?
Thank you for the question. First of all, I'd like to say that we are putting this plastic container inside the well because the temperature in the well is stable in any season and in any weather, and because of the lower level of oxygen like inside of the well, the number of the bacteria do not increase, and this helps to keeps the water inside of our reservoir it makes it last longer, and it stays for with a good quality for a long time.
But it's more difficult technically than near the well.
Yes, technically it is a little bit complicated, but as I said, it helps when it is inside the well. It helps it to be better and to be good for a long time. And if it is outside, the weather can change its quality, and it can be not so good for not only the personal use to drink or either to have it as a technical water.
Thank you.
Okay, more questions? Okay, if we have no questions to our super finalists, so we are going to the next project. Приходько Єлізавета. Оцінка природно-антропогенних трансформацій Карабутівського водосховища за даними різночасових супутникових знімків та геоінформаційних систем. Путивльський ліцей номер 1, Сумська область. Єлизавета, are you ready?
Yes.
Okay, you can start.
Good day. I am presenting a report on the topic Assessment of Natural and Anthropogenic Transformation of Karabutyev Reservoir. Next slide. The Karabutyev Reservoir is the largest in Sumy region, characterized by a reduction in water surface area alongside intensified processes of siltation and eutrophication. Therefore, addressing these issues requires immediate action, as water quality is a key factor in sustainable development. The primary object, and subject of the study presented on the slide. Next slide, please. To achieve the objectives of the scientific research, methods of analysis and synthesis, mathematical analysis, cartographic and illustrative methods, as well as remote sensing and GIS methods were employed. Also, we used Google Earth Pro, EO browser, QGIS, and calculated in the WI and in DVI indexes. Next slide, please. Using Google Earth Pro, changes in the area of Roman Reservoir from 1985 to 2021 were established with the map presented on the slide. The map clearly shows us the overgrowth of a reservoir in its upper reaches. The maximum recorded area of the water body was 4.26 quad kilometers in 2009, and the minimum was 3.23 quad kilometers in 2020. In CSV, Microsoft Excel and dual serial values from in the WI and DVI were determined. It was found that the maximum DWI value of 0.27 recorded in 2019, while the minimum of minus 0.61 occurred in 1999. Maximum in DVI values of 0.66 recorded in 1999, while the minimum of minus 0.31 occurred in 2001 and 2002. The NDWI trend line from 2017 to 2024 shows a clear downward trend, while the NDVI demonstrates an upward trend, indicating enhanced processes of eutrophication. It was established that the eutrophicational process intensified from May to September, likely related to physiological processes in plants and intensive warming of a water body. Those maximum NDVI values in June and September were recorded on 7 occasions. The minimum active biomass content in the water was observed in March 8 times. Maximum water content was recorded in March 20 instances and April 7 times, linked to the predominance of snow melt in the Roman area on which a reservoir is located. Minimum threshold values for water content were characteristic of June 8 times. Next slide, please. Between 1985 and 1989, the NDWI values were lower than 0, often ranging from minus 0.2 to minus 0.4, with a downward trend. The NDVI fluctuated between 0.2 to 0.4, also showing a declining trend. In the period from 2019 to 2023, the NDWI trend line moved towards negative values, while the NDVI trend moved towards positive values. The threshold values of NDWI were higher compared to previous years, approaching 0.2, whereas the threshold values of NDVI were quite high, around 0.4. Next slide. To investigate changes in the reservoir's ecosystem, an analysis of NDWI, NDVI, and NDCI was performed for the delineated polygon of the water body using raster calculator in QGIS. This analysis allowed for identification of changes in water content and vegetation. The pixel values in the calculated NDWI histogram for 1984 ranged from 0.762 to minus 0.04, while in 2024 they ranged from minus 0.854 to 0.473. The decrease in water content was characteristic of the upper reaches of the reservoir, while water content near the dam increased in 2024. The pixel values in the calculated NDVI histograms for 1984 ranged from 0.11 to 0.823, and for 2024 from minus 0.237 to 0.928. Next slide, please. By visually mapping the differences in indexes, corresponding maps were created, and these maps confirm the transformation of upper reaches of the reservoir. Next slide, please. An analysis of land use characteristic in the study area was conducted through manual interpretation of Landsat 4.5 and Sentinel-2 satellite images using the Dzaka plugin in QGIS. The images clearly depict the transformation of the upper reaches of the reservoir and increase in built-up areas. Next slide, please. I will refrain from reading the conclusion as they are presented on the slide. However, I would like to note that the results obtained corroborate field studies presented in the work Danilchenko, particularly regarding the transformation of reservoirs' upper reaches. Thank you for your attention, and that's all.
Thank you, Lisa. So, questions, please?
May I be
Yes.
first? You see, if you show somebody this presentation who don't know about your work, probably the first question will be as why you use different periods to compare different data. For example, you at first compare period from 1985 to 1989, and then compare with 2023 years. And in different investigation, we compare different periods. And in your finally records, you show some period of time between 1985 and 2021. How will you explain this fact?
Thank you for your question. We are using different time period really to compare the vegetation process and water quality of reservoir in different period of times.
Okay, thank you.
Thank you. More questions? I have one. What are you going to do the next in your research? It should be something new in framework of this work, or are you going to do something new one? So what is your plan?
Thank you so much for your question. Yeah, it's really interesting. I want to make the item of my project wider, maybe to investigate the correlation process of the reservoir. Also, maybe to investigate the chlorophyll, missed chlorophyll or chlorophyll content, because in our research we are using NDCI index. That's the index that's like NDVI investigate vegetation, but also this index shows us chlorophyll or cyanobacteria and such things in water if they are in the water. But I really like to investigate this question wider, and also maybe to make a recommendation how to make a reservoir quality of water in reservoir better.
Thank you. More questions? Okay, if you have no questions to Lisa, so we move to the last one presentation for today. Так, Чумаков Ігор. Вплив токсичного забруднення водойм міддю на захисні метаболічні системи в організмі риб. Дніпровський науковий хіміко-екологічний ліцей, місто Дніпро. Ігор, are you ready?
Yes.
Please start.
So great. As I have been introduced, let me now read this slide and go to the next slide to focus more on the relevance of the study. So the relevance of the study, there are 3 copper ions up to 20 microns per liter are recorded in Ukraine water bodies after full-scale invasion, which is 20 times higher than the permissible norms. The literature analysis showed us that the chronic effects of such copper concentrations on a fish have not been studied. Therefore, an aim of our work was to investigate the effect of copper this concentration on the activity of antioxidant protective enzymes, histological and morphophysiological parameters of fish. The model object was the guppy fish. Software, cell profiler, and imaging were used, as well as Python programming language. Next slide, please. So, experimental and control fish were kept in 5 different aquariums with 20 fish in each. The copper concentration of 20 micrograms per liter was maintained by adding the calculated amount of copper sulfate, with a complete replacement of 20% of water every 3 days according to the methodology. The duration of the experiment was 21 days. Next slide, please. Let's move on to the results of the study. We found that malondialdehyde was increased significantly in all tissues studied, most of all in the gills by 52%, in the liver by 33%, and in the muscle by 5%. The table below shows us the results of glutathione transferase activity in guppy tissues. We can see that the activity increased only in muscles by 25% compared to the control. Next slide, please. Let's discuss about copper's exposure on tissues. So, in the control group, hepatocytes had clear boundaries, nuclei were most located in the center, and cytoplasm was normal. In the experimental group, the hepatocytes lost their sharpness of contrast, and the nuclei were deformed and shifted to the periphery. Next slide, please. In the control group, the gill structure was typical, the lamella were of equal shape, and epithelial cells are well defined. While in the gills of experimental group of fish, we can observe curvature and thickening of the gill lamella and hyperplasia of epithelial cells. The consequences of this pathology are a decrease in the gas exchange area and impaired respiratory and redox processes. Next slide. In the control group, fat vacuoles were located on the periphery and occupied a small area, and most of them were filled with a homogeneous dense yolk. In experimental group, eggs changed significantly. Firstly, the number of fatty vacuoles increased, occupying almost the entire area of the egg. Secondly, the yolk showed signs of stratification. These changes make it impossible for eggs to mature normally and can lead to infertility. Next slide, please. Morphophysiological parameters. So the effect of copper was detected only on fish respiration. The respiration rate of females increased by 15% and that of males by 13%. Next slide. As an innovative solution to reduce copper contamination in water bodies, we propose the creation of a constructive wetland. We propose to use air water plants and dry xena mollusks because it is well known that both have high accumulation rates. Our structure will have to be installed in the lower part of the reservoir, closer to the fish spawning period. The areas of spawning are clearly known. The idea behind our approach is to prevent newborn fish from being exposed to copper. As soon as it gets colder, we will have to cut the vegetation and catch mollusks. The next launch of the constructive wetland will take place in a year, closer to the next spawning of the season. Thus, our design is seasonal and does not require constant maintenance. The next slide. In summary, our studies show that chronic exposure to copper at a concentration of 20 micrograms per liter caused oxidative stress in fish, as evidenced by a significant increase in malondialdehyde and inhibition of glutinase transferase. The result of oxidative stress was fatty hepatosis, degradation of gill apparatus, and disruption of normal egg maturation. Let me now read the conclusions. They are presented on the slide. That's all. Thank you for your attention.
Thank you, Igor. So, question. I can start from my first question. In case of our wartime in Ukraine, what do you think? How you could continue your investigation? Maybe you can add something in future.
Yes. Okay,
so how you can connect the wartime in Ukraine, the results of your research, and how you can share these results in not only in your region, but all over Ukraine and other territories with such situations?
So, firstly, about war connection with war. So we have articles which show us that copper concentration of 13 TLH threshold limited value was observed in the Zaporizhzhia region, in Kyiv region, and Zhytomyr region in 2019. But then we have articles of the same areas maintained, and there was a copper concentration higher. So we see the connection between full-scale invasion and an increase in level of copper in these water bodies. So that's firstly. Secondly, how can I share these results with others, right? So, well, pollution of heavy metals pollution is not a problem limited only by Ukraine. It's also observed on all over the world. Just like I said yesterday, we have articles that shows us the concentration of 20 micrograms per liter and even higher in the United States, in Philippines, in Indonesia, in Brazil. So it's not only problem limited to Ukraine. So my results can apply to those water bodies as well, because copper pollution of copper, it's not only caused by war. It's caused by war here in Ukraine, but it's not only war. It's not because of war.
Okay. If your method of investigation is it the same like in other research, in other countries, or you have something new?
What do you mean? Can you please?
Method of your research. Method of your research.
Well, we measure the concentration of copper. We built like an experimental group. We conducted the model experiment to see how fish reacted to higher copper concentration. But what's new about our project is that we investigated the exposure of background copper concentration, which is actually observed in the water bodies. Therefore, the results of our study allow us to predict the further development of ictiocynosis. In particular, we can say that fish degrade the detoxification function of the liver, which makes fish even more vulnerable to all types of pollutants and will lead to a decrease in population. While most of the researchers were investigating another concentrations of copper, little and sublethal concentrations of copper in short term. But we were investigating chronic effect.
Okay. And my last question is about how your results could be implemented, for example, to the copper in body health, human body health. Is it any connection with it?
Between copper and human body?
I mean, your results of your project.
Yes.
Do you see any connection with how this copper could influence on human health?
Well, actually, no, because when we eat fish, we mostly eat mussels, right? We don't eat liver, well, mostly we don't eat liver or gills. And as you can see in the table, the least contamination of toxic copper and malondialdehyde was observed in mussels. So we can eat that fish, but the problem is that fish is exposed to copper significantly. And just like I told you, also the new idea of our project that we conduct research on maturation process, and we show that this copper can lead to infertility actually. So yes, there is connection.
Okay, thank you, Igor. I finished with my questions. Who can continue?
May I?
From jury. Yes.
Will you plan study impact of different heavy metals on the fish?
Well, yes, we can. Well, mostly, I see like two possible ways to continue this study. First, we want to make research to see how newborn fish will react to this exposure of copper, firstly. And secondly, we want to make better technology of constructive wetlands. So basically, it's our two options, but yes, we can. We actually can make research in different heavy metals, why not? But we choose copper because, just like I told, we see the connection between war and increasing of copper. We cannot see that with cadmium or zinc or other heavy metals.
And in this case, your proposition for protect fish with use some island areas, is this proposal will be universal, or you will see other improvement of this technology?
Well, it's universal idea, but I mean, by improving this technology, I meant that maybe use like bigger constructive wetlands, or well, look, the main idea of our wetlands is to place it in the lower part of reservoirs, so the newborn fish will not be exposed to this copper concentration. This is the main idea.
Okay, thank you.
Thank you. Any question?
I have questions. Maybe thank you very much for your presentation. It's really very good presentation and very good job. The first question is more or less private. You have beautiful level of English. Tell me, please, where it appeared. You lived somewhere in another country? Yes.
No, I've never been to another country, but my teachers, I studied English with foreigners. So my teacher was from Canada, and then I have teacher from India, Gabriel. So that's why.
Yes, my regards to your teachers. Best regards to you.
Thank you.
Your job also is very, very well, and but your level of English is very, very surprised me, and very good characterize your total level. of education. Okay, now the question about your work. Maybe I'm wrong, but it seems to me that this method may be used as indicator method, which will show the cleaning or the dirty of water area. Is it? Am I right or not? Can be the change in fish statement show us that water in this, for example, lake or river is really dirty. And
Yes,
the second question, it can be included to the first question. Why copper? Why only copper? Because really copper is more or less popular in our river sources. But sorry, excuse me, please. But as show my personal experience, more effective for these investigations could be mercury. Okay, it's
so answering on the first question, of course, yeah, we can use my research as an indicator method. Like, why not? We can, because copper it exposures the liver and it degrades the detoxification process which take place in liver glutathione systems. It causes the swelling of cytoplasm, the breaking of endoplasmatic reticulum, and swelling of nuclei. So yes, we can. And also for gill apparatus, the same. We can see the significant changes in gill apparatus, which caused by chloride cells within it. And also sodium plus and potassium plus ADPase enzyme is degradation, shows the degradation under the copper exposure. So yes. Answering the second question, why copper? Well, just like I told, because our idea, well, again, when we were analyzing the literature, we saw the connection between full-scale invasion taking its place and increasing copper. That's why we choose exactly copper for our investigation and not other metals. But of course, heavy metals, copper is not the only heavy metal, of course. But we choose copper because of this.
Thank you.
Thank you. More questions? Так, я не бачу більше питань від членів журі. Отже, колеги, ми з вами заслухали всі 6 презентацій суперфіналістів. Що ми робимо наступне? Я пропоную членам журі залишитись на обговорення в цьому чаті Zoom. Суперфіналісти і керівники можуть від'єднатися і давайте орієнтуватися десь за годину. Давайте 13:30 ми зустрінемося тут з вами. Зайдете за цим самим посиланням і ми будемо робити оголошення результатів. Всім дякую. Члени журі залишаються, учасники, керівники відключаються. Так, отже, колеги, 13:32. Ми майже всі тут з вами для того, щоб почути, побачити результати роботи журі по визначенню переможця і призових місць Всеукраїнського юнацького водного призу 2025 року. Я вивожу на екран свою презентацію, але перед цим хотіла би ще раз всім вам подякувати за участь, керівникам за ту роботу, яку ви робите, з молоддю, за ту підтримку, яку їм надаєте, молоді, безумовно, за те, що ви продовжуєте працювати і вирішувати поки що на своєму рівні. Я впевнена, що ці проекти знайдуть своє продовження в подальшому тих водних проблем, які є в Україні і світі. І я дякую нашим членам журі за те, що вони долучилися і взяли участь в оцінюванні ваших робот, в дискусії. Окрема подяка нашому спонсору компанії «Екософт». Це компанія, яка є одним зі світових лідерів в галузі локальної і загальної водопідготовки, і яка останні 15 років, вже 16, можна сказати, підтримує цей конкурс, попри всі обставини. Я би хотіла надати слово голові журі Тетяні Євгенівні Міченко для того, щоб розпочати оголошення результатів.
Так, я дуже рада всіх вас вітати. Мені дуже приємно знову зустрітися з учасниками українського водного призу і відзначити, що незважаючи на війну, незважаючи на ці жахливі часи, в яких ми зараз живемо, все ж таки ви знаходите час, натхнення і керівники, і діти, які виконували ці роботи, показують себе з дуже такої яскравої сторони, і всі роботи нам дуже подобаються, і вони є актуальними, в них використані дуже високого рівня обладнання, і результати робіт добре проаналізовані. Тобто, все гаразд, мені все дуже, оскільки ми вже більше 20 років проводимо цей всеукраїнський юнацький водний приз, є з чим порівнювати, і рівень робіт достатньо високий і в всякому разі не нижчий, ніж був до війни. Щодо наших сьогоднішніх учасників і розподілення місць, які вони зайняли. Третє місце, Юля, третє місце зайняли роботи Василя Єременка, автономна установка для очистки стічних вод на основі штучного китового вуса з авіаційного ліцею імені Сікорського міста Києва. Я буду трохи висказувати свої думки згідно кожної з робот, в тому плані, що, може, вони будуть почуті і коли якось використані самими учасниками. Робота, безумовно, дуже цікава, дуже оригінальна, дуже така, я би навіть сказав, творча, безумовно, але і дуже красиво ці 3D-проекції, і машинка, це все має значення для так сказати, участі в цьому конкурсі. Проте мені здається, що треба її допрацювати в тому плані, що окей, це відносно новий спосіб очищення стічних вод від твердих домішок, але він не зовсім допрацьований. І якщо ми звільняємо воду, по-перше, Василь казав, що він фільтрує тільки органічні домішки. Це чудово, але коли йде стічна вода, вона не питає, які домішки її вміщати. І там, безумовно, немає такої стічної води, де були б лише органічні домішки, якщо не рахувати, звичайно, ту воду, яка утворюється в туалетах. Але, наскільки я розумію, там дійсно лише органічні домішки. Але, наскільки я розумію, Василь мав на увазі дещо інше. Я так розумію, що якісь залишки рослинного походження чи щось. Проте не буває таких стічних вод, де були б тільки залишки рослинного походження, там, безумовно, є все. І пісок, і глина, і уламки чогось іще, і так далі, і так далі. І що робити з тим шламом? Якщо Василь буде розвивати це все, ми готові прийняти його роботу ще раз наступного року. Але треба звернути саме на це увагу, що таке рішення повинно бути комплексним. З одного боку витікає очищена вода, яка йде, от ти кажеш, на хімічну очистку. Ну, потрібно було б якось уточнити, яка саме хімічна очистка повинна використовуватись. І найголовніше, що робити з цим шламом, куди його. Але все одно робота цікава, робота приємна, і вона зайняла 3-е місце, і Василь буде премійований грошовою премією в розмірі 3000 гривень. Також 3-е місце зайняла робота Варвари Макряк і Ганни Кисельової «Система накопичення питної води Волвотер». Хороша робота, хороші дівчата, все нам дуже сподобалось, але, ну, 3-е місце теж 3000 гривень. Далі, Юля, в мене...
Так, зараз буквально, ще, будь ласка, трошки прокоментуйте. В мене технічна заминка з презентацією. Зараз мені буквально півхвилиночки потрібно. Перепрошую, щоб показати наступний слайд. Бо з'їхали слайди.
Ну, я, звичайно, можу побажати Василю і дівчатам продовжувати ті роботи, які обидві роботи дуже цікаві, дуже перспективні і мають великий шанс при їх продовженні, навіть як на нашому конкурсі, так і на інших конкурсах, звернути на себе увагу і зайняти більш високі місця.
Так, зараз вивожу 2-е місце. У мене щось сьогодні...
Щось сьогодні у всіх
Так,
стоїть
зараз
води.
поширити. Так.
Так, переходимо до 2-го місця. 2-е місце у нас зайняли аж 3 роботи. Дуже близькі були оцінки, майже не відрізнялися одна від одної, і тому ми присудили 2-е місце 3 роботам. Юлія, але я тут бачу 2. 3-я
Ні,
не...
ось 3-я є також. В мене просто з'їхав цей слайд, і перша робота Вовк
тобто
Павлюк
Приходько Елизавета просто не виділена чорним, да?
Так.
Окей. І так, 2-е місце в нас зайняли Антон Вовк і Маргарита Павлюк з роботою «Особливості використання дистанційних даних для оцінки водності території на прикладі Волинської області». Робота дуже цікава, дуже сучасна, і складається враження, що і Антон, і Маргарита чудово володіють інформацією, яку вони одержали, і є, можна сказати, спеціалістами у цьому питанні. Вони одержали високі оцінки і зайняли 2-е місце. Такі ж оцінки одержали Поліна Голощанова і Анастасія Білименко з Ніжинського фахового коледжу з роботою «Система для очищення та аналізу якості води ДРОН-СОМ». Теж робота нам дуже сподобалася, вона цікава і свідчить про високий рівень виконавців цієї роботи. І нарешті теж 2-е місце зайняла робота Єлізавети Приходько «Оцінка природно-антропогенних трансформацій Карабутівського водосховища за даними різночасових супутникових знімків та геоінформаційних систем» з Путівльського ліцею номер 1 Путівльської міської ради Сумської області. Ну, це одні й ті ж самі слова, але вони абсолютно правдиві, і я дійсно підкорена тим рівнем інформації, тим рівнем знань, яким володіють виконавці оцих 3 робіт. Це просто чудово і не вкладається навіть в голові, як такі молоді люди можуть так вільно і спокійно оперувати такою сучасною, досить складною інформацією. Я вас поздравляю з 2-м місцем. Кожна робота одержує премію в 4000 гривень, і ми сподіваємося до наступних зустрічей з вами. І нарешті, Юля.
Так, перемкнула, видно?
Ні, я бачив попередній слайд.
Зараз, давайте так.
Ага.
Угу.
І нарешті гран-прі, перше місце зайняв Ігор Чумаков з роботою «Вплив токсичного забруднення водойм міддю на захисні метаболічні системи в організмі риб» з Дніпровського науково-хіміко-екологічного ліцею з міста Дніпро. Ну, я вже відзначала чудовий рівень підготовки самого Ігоря, проте робота також дуже цікава і дуже сучасна, і дуже актуальна, тому що ми всі з вами знаємо, яка якість води взагалі і в світі, і в Україні, і, зокрема, в Україні, як вона погіршилась під час війни, і тому ці дослідження, які провів Ігор під керівництвом свого керівника, вони дуже сучасні і принаймні для України вони можуть бути активно використані навіть в тому вигляді, які, в тому розмірі, в тому об'ємі, який є зараз. Але якщо Ігор продовжить працювати в цьому напрямку, то він може досягти ще більш значних результатів. Ми йому бажаємо всього найкращого на цьому шляху і теж сподіваємося на наступні зустрічі. Саме Ігор поїде до Стокгольму представляти нашу країну в серпні місяці на Всесвітній водний тиждень і буде представляти свою роботу, і ми абсолютно впевнені, що він це зробить прекрасно. Все. Да, крім того, ми знайшли можливість відзначити всіх керівників робіт і теж невелику премію, але 2000 гривень кожен з керівників одержить за ту роботу, яка була ними проведена. Дуже дякую всім, бажаю якнайбільших успіхів. Я вже багато років виступаю в якості керівника журі, голови журі цього конкурсу, і кожного разу зустріч з виконавцями, зустріч з вами мене надихає на подальші кроки в цьому напрямку. Тому що, якщо в країні є такі талановиті діти, якщо в країні є така цікавість до екології, до якості життя, до якості води, то ця країна буде стояти вічно і ніхто нас ніколи не переможе. Тобто, всього вам найкращого. Бережіть себе і бережіть рідних.
Дякуємо, Тетяна Євгенівна, дякуємо ще раз всім членам журі. Колеги, отже, офіційна частина в нас така пройшла, ми вже всі знаємо свої результати. Організаційна інформація щодо того, як ви отримаєте дипломи і премії, буде надіслана вам на електронну пошту. Окремо ми зв'яжемося з Ігорем для того, щоб взяти в нього коротеньке інтерв'ю для нашого журналу «Вода, водочисні технології», щоб він з керівником поділився своїми враженнями. Тобто будемо з вами на зв'язку. Якщо у вас будуть якісь питання, також можете мені писати на пошту. І ще раз вам всім дякую, бережіть себе, бажаю вам тихого дня, працюємо далі. Дякую вам, до побачення.
Дякую, до побачення.